There we go. Okay, so, ladies and germs, and whatever else in between, attack helicopters, Apaches, it looks like I'm doing a product review, which means I need to create a brand new title page for this thing. So, this is the iLepo multifunctional DC UPS thingamabobber in black. Alright, so, looking here. 120 volts AC, 50 to 60 hertz, max output power 15 watts. Let's see here. Output, USB, DC, or POE. Voltages are 5 volts on USB, obviously, 9 to 12 off the barrel connector, 15 to 24 off the POE. So it's designed to work with, like, either, basically just low-end point-to-point links or point-to-multipoint client radios and whatnot. So, looking closer here, let's see here. Yeah, so 4, 5 are positive, 7, 8 are negative. That's standard for Ubiquiti and MikroTik, and pretty much everybody else uses passive PoE. Output power, 2 amps, 10 watts in common. So total output you can actually achieve off this thing is 20 watts. We're going to put that to the test anyway, and then we're going to tear it to pieces. Alright, so, oh no, sorry, that's the USB. 10 watts. The DC interface can give you 12 watts, and the PoE can give you 15 watts, or 10 watts and 15 volt. So yeah, just a little thing on here, built-in lithium battery, blah, blah, blah. It's basically just a UPS, okay? Warm prompt for getting more fun and multifunctional convenient operation. Please read carefully the user manual. Before you use this product, please charge the power bank once every 3 months if the bank not be used for a long time. Great English. It is normal that the temperature is a bit high during charging. Please keep the bank clean and dry. Do not wash the bank with chemistry depurative. Okay. I'm not making that up. That's there. Alright, focus, focus, focus. There you go. Weird. That hurts my skull. So it's made in Shenzhen. Cool. So, alright, so here's the unit now. And what you can see here is that it's a little thing. If you look closely, you'll be able to see that it's at 75%. It goes 25, 50, and 75%, 100%. And for some stupid reason, I can't get it to go to 100%, which really kind of bothers me. So, I don't know. But let's do some tests. So this thing's charged right now. I'm going to unplug it. We've got your AC input on it, up to 240 volts AC, 9 volt to 12 volt selector for the barrel connector on the DC. And then here's your PoE out. So here's your LAN, your pass-through in that. I should probably check to see if it's gigabit. But that's not the point of my test right now. I'll put in the comments below if this thing does test out to be proper gigabit through the port. But anyway, let's get to testing this thing like electrically now. So obviously, you know me, I like to make shit. So I made a little watt meter thingy here so that we can measure this properly. Let's see here. One of these is the DC in. I believe that's the right one. Yay. Okay, so this will show us the power. So it's going to show us the voltage, the wattage consumed, and amperage consumed. So first things first, let's start plugging shit in. And remember, by the way, devices like this or radios and that, the higher the duty, the more power it's going to consume. So if you start pushing a lot of packets through one of these routers, it's going to consume more power. So when you're using something like this, consider the maximum power consumption of the devices when you're working out if it will work on it. Don't just go, well, I plugged it in and it works, and then have customer complaining, or you run into your own issue where you start pushing 200-300 megs and then this thing dies. It cuts out, because it will. Alright, so let's plug in a router board. Alright, so first we've got this guy. We've got about 2.8 watts going on here. I'm going to really load this guy down, by the way. So there we go. Alright, so we're at 3 watts now. Now let's plug in a 2.4 gigahertz feed horn. And see how much power it uses. Let's see if we can really bugger this thing up. I've got a NanoStation M5 here too. There we go. Plug that guy in too. Just keep climbing the wattage. I want to see how many devices we can actually throw on here. I wouldn't suggest putting more than 3 items on here anyway, realistically. I wouldn't suggest putting more than 3 items on here anyway, because realistically, once you start to push some traffic over this thing, it's going to crash. Because, like, this guy here, I think it's rated for 6 watts on its own. Something like this is rated for about 6, so that's 12 right there. And this guy here, I've seen them pull as much as 12 watts by themselves when you really, you know, amp them up. So that's what we're getting right now. So we got 6.2 watts. I don't think this is powered up. There it is. Okay. So with no load, none of these radios passing traffic, I can see that we're getting about 6.2 watts here. And look at the voltage drop. We're still just at 23.94. So that's not terrible. What else can I throw on here? Let me see if I've got another radio kicking around. Let's see. It says NFG on it, so chances are it's borked. So let's just try that. Here we go. Let's see if I can get that to power up. But so far so good. I mean, it hasn't crashed yet. We're gonna make it crash, by the way, of course. All right, let's plug this guy in. It's an NFG, so well, it's taking power, so that's a good thing. So that's suitable for our test here. So we're at 8 watts. We're running 8 watts right now. That's pretty decent. 8 watts. This configuration here will more than likely cause this thing to fault once you start pushing a lot of traffic through it. Because, like I said, these guys are masters of power management. The CPU will draw more power as you load it down. Alright, so there's that test anyway. One thing I'm going to try now, we're going to try plugging a light bulb into this, like a dummy load that I've made. I just want to see what will happen. So this should be a 1 amp load. I'm just going to plug it right into the MikroTik. Let's unplug all this stuff first, though. Alright. Okay, so hopefully it auto detects that. I don't know if it will or not. Let's give it a second to see if it does. So that's 24 volts. No, it doesn't seem to want to trigger it, so give me a second. We'll hook it up slightly differently. Okay. Alright, I'm not even gonna... should I put the watt meter on? We will. Okay, so I think I've got something I can use to bond this. I should have a POE I can use. Or something. Yeah, you know what? Who cares? We don't need to know exactly how much current it's drawing anyway. Unless, hold on. Let's just do this. Screw it. Okay, so what I'll do is I'll put this thing in line. Jerry-rig everything. Alright. Let's see what happens if we turn a light bulb on this thing. So we're on the 24 volt. And here's one. Oh, whoops. That's my bad. Hold on. There we go. So that's about 1.5 amps, and 1.5 amps. We'll trip it. Now let's see if it'll come back on its own. No, it does not look like it. This thing is faulted. So let's see what it has for fault recovery. Let's just be fair and give it like a few seconds. I would call that an epic fail. So note to yourself, if this thing faults and you've got this at a tower site, you're gonna have to go to that site and reboot this thing. it will not fix itself. Alright, so now that all that shit's out of the way. Alright, let's crack it open and see what we got here. I figured this camera out, by the way. Apparently when I've got my view screen connected to it, it will only record 3-minute segments at a time, which I hate. It's a real pain in the ass. Oh, sorry, one other thing I should note. What do you see for actual safety ratings? Sure, it's got CE on it and FCC, but I'm guaranteeing you those are both bullshit, because I'm not seeing a UL or a CSA or any other type of proper home safety certifications, you know, like Underwriters Labs, Canadian Safety Authority, ESA for Electrical Safety Authority, and I'm willing to bet that anything here is going to be counterfeit as well. Alright, so my counter's about to reset again. Alright. Let's get her open. Oh no, I broke the safety seal. Alright. What do we got here? There's a company out of Louisiana there, I believe, that uses these guys all the time, and they've already had a couple apart. Ugh. Okay, so these look like recycled 18650s. Alright, so we got 4 18650s in here in a 8.2 volt configuration. One of the cables is really pinched here, clearly because this is hand assembled. Let's see the pack quality. We've got some rust there on the battery. It feels legit. What are these ones? I think they're Sanyo. Correct me if I'm wrong. I mean, like, here's the numbers, so check them out and tell me what you think. But anyway, there's the circuit board. So this is a really clever design, except I'm seeing that there's really no major isolation between the AC and the DC here. Let's see what we've actually got on the board. See how safe this thing actually is. Where's my big plus? There's my big plus. Nope, that's my small slot. A slot screwdriver. Let's see what we got here. Alright, so there's no physical isolation between the AC and the DC side of this thing. That's a little concerning, and that would not pass Electrical Safety Authority here in North America. I'm almost certain of that. I should actually check for reference to mains on here. Yeah, that's kind of sketch as hell. I mean, like, you can clearly see here, that they've actually isolated the PCB physically around most of the AC section, and then here's the coupling transformer on that going across. But yeah, there's really no cuts in the board. There's no proper physical isolation between the AC and the DC side, which is probably why it doesn't have a real safety certification on it. Alright, let's see what else we can see. Yeah, I think I'm going to plug this thing in and just check if there's any kind of a reference to mains on here. We're going to plug this guy back, put it back together and test it. Let's see here. Put our screws back in. Now remember, since they're running these guys like in 8.4, I think the reason why they're doing that is because there's a 9-volt output on here. Because they're using like a boost conversion circuitry to bring the voltage up. But when you're boosting from 8.4 volts up to 24 volts, 15 watts at 8 volts would be what, like nearly 2 amps coming off of these batteries, which I think is why they chose to keep it down to 15 watts for this thing. Alright, so let's see something here. Alright, we're going to plug it in. We're going to turn it on without a battery. Oh, would you look at that? Hey, folks, look. No battery connected. 75%. Huh, isn't that's kind of odd. So, Are you telling me right now that the battery meter does jack shit? Or that the output voltage is low? Alright, let's check something else here, okay? So clearly red and black. So let's get a multimeter here. It should be 8.4 out if it's charging these batteries properly. So let's see what the output voltage is on this. First of all, let's see here. Oh, wrong way. So this thing is only putting out 7.5 volts, which means it will not charge those lithium cells to full. That's a little concerning. Let's just plug the battery pack in and just see if I'm not like on crack here. Because that's actually going to wreck these batteries in a very... they won't live their full life if they're never fully charged, so... Yeah, look at that. They're idle at 7.6. This should be putting out about at least 8 volts to charge these batteries properly. Each cell's 3.7. These cells typically peak out about 4.2, so keeping them around 4.1 is your float point for these guys, I guess you could say. Alright, so that's already failed the test there. That's not good, because you're not going to get the capacity that these are rated for at all. You're probably losing about 20%, 30% capacity because these aren't charging to full. Alright, so now the next test we're going to do here is we're going to test mains reference on it. What's that plug for? Alright, so now let's see what we've got for mains reference. Okay. So I'm just going to go off of, let's just go off of neutral here. And what do we got? Yeah, 2 volts, that's not terrible. Let's see off the other one. Oh, 10 volts off of the mains to the USB. Huh, 10 volts AC. So it doesn't look like there's great AC isolation here anyway. That's kind of unnerving. Let's check over here. I'm just gonna... I might end up blowing this thing up, but whatever. Okay, so let's go off of our negative here. I'm not gonna put my finger on that because I might get zapped. Okay, let's neutral. There we go. Neutralize that. Holy! Would you look at that? 55 volts AC from the mains to the negative output on the POE. 48 off the other pin. Let's try it on the positive now and see what we see. 55. Ho ho, folks, we've got mains reference on the DC output of this thing. Ha! Just as I thought. This thing's sketch as hell. 55, so right from the AC over to here we've got mains reference, okay? That's great. Just beautiful. And let's just double check the voltage on the batteries again. We'll go back over to DC. Here we go. Yeah, it's pretty steady at 7.6. So these batteries will not reach full, which means that whatever watt-hour or amp-hour rating is on the back is useless, because if they're not topped up to at least 8 volts, they're not reaching their full capacity. So 7.6, that would be 3.3 volts. So not even 3.7 volts, not even 4.2 volts, which is the top charge on this. I'll see if I can modify this. I'm not going to put a ton of effort into it, because it's just a cheap thing I bought to test out. But I'll see if I can re-engineer this and replace a resistor somewhere and try to up the voltage going up to the lithium-ion cells and maybe, you know, fix it that way. But yeah, that's the general rundown of this thing. So we've done our teardown, we've done our mains reference test, we've done our current tests, our fault tests. Would I use it? I don't know if I would. Actually, you know what? Let's do a ground reference test on this thing just to be safe, okay? So I've got ground right here on my meter, or on my power supply. So I'm going to go from... Oh, hold on. Okay, so here we go. So let's go from ground. First of all, I'm going to put this meter right over here. This is an auto-ranging meter, which is why it goes a little wonky. So going from ground, you can see I've got 125 volts on one pin and 0 on the other, because the 0 is supposed to be the neutral. I shouldn't be getting 800 volts. I think that's a false reading, static maybe. Okay, so we've got There, now I'm going to try going here. Yeah, so right to ground, we've got 49 volts, right? Okay, and let's go to the power on these pins here. 49 volts to ground. Alright, so this thing may potentially be a liability. That's my opinion. I don't know if I would use these. They're clever and they look great, but clearly they're a piece of dog shit in their design. I mean, if I mod this thing, it might work a little bit better, but I don't know if I'd trust it. I mean, like, clearly tons of people have used these things, and they haven't burned down anybody's houses yet. But, I mean, there's reference to mains on most of the outputs on this device, which is not great. Yeah. The batteries aren't charging to full. They're only charging to, like 70-80%-ish. Somebody out there who actually has the time to do the math, just do the math for me and calculate it. But, so, I mean, like, it's not what I would call or consider a quality product, and it's not something I would leave at somebody's home. Or even at a tower. I just don't think I'd really use it, because, I mean, like, if this thing faulted and electrocuted somebody, you're on the hook. That's a liability right there. You may actually get, somebody might sue you, especially if you're using this in America. The other potential I could see running into is that, just the batteries, really. I mean, like, this isn't reliable. I can see with the batteries not charging full, you're not going to get the runtime out of it you expect. This may potentially stop disconnects, because as you know, if the radio loses power for long enough, it will disconnect and then it'll have to reconnect. And if your customer is like running a business or something and there's a flicker, and this is not on the UPS, then it'll flicker. So I just think a small UPS is a better idea than this thing. But that's just me. I mean, like, that's my opinion. You guys weigh it up for yourselves now that we've seen some tests on it and, you know, screwed around with it a little bit. We know what to expect, right? So, I myself, I'm going to use one of this because I did buy it for an intended purpose, to get fiber to my house. I'm doing a point-to-point link from one of my clients' places. I'm probably going to take some precautions on this and set it up slightly differently. And, yeah, so that's my take on that. Okay, so for the last test here, I'm going to plug this thing back in, but I want to see if we're going to get any problems if we go to mains on this thing now. So let's just, I'm not afraid to blow a light bulb in the name of safety. Alright, I need a jumper cable. Alright, so here's our ground. And we're going to connect that to here. And now let's get our little jumper here. And let's see what happens if this thing comes into contact with Earth, okay? Well, that is good. There is not a ton of current coming off of there. Oh, it's not turned on. Hold on. Now it's turned on. Let's see what we get here. Realistically, if there's bleed, there's bleed. Okay, so I'm not seeing a problem there. Let's turn it up to negative. No, so there's like no current there. And in fact, let me take one for the team, folks. I'm not feeling anything. No, so it's not a very high risk of getting zapped off of this, I guess. But there's still mains reference on it. So, I don't know. Use your own discretion. There's tons of people using them that have no complaints that say that they work great. This is just my teardown and overview. I'm probably still going to use this unit. It's just, this is what I think about it. The biggest problem with this thing is that the battery pack is not reaching full charge, which means that the batteries will degrade over a lot less time than they could potentially last to. Yeah, and it only has 15 watt output, so Yeah, do what you will with it. But I guess the last test I'll have to do is I'm going to do a battery capacity test on this to see what the batteries actually are. And the other test will be to see how much runtime we can actually get out of them at that voltage. So I'll post those in the comments later on, or maybe a follow-up video. Alright, because my video got cut off, again, if anybody knows how the Sony DSC RX, I think it's a DSC RX 100, but anyway, I've got a Sony, you know, it's supposed to be a vlogging camera, and for some reason it cuts off at 3 minutes when I think the HDMI is plugged into it, so I can have my screen right here to watch what I'm doing. But anyway, that would be amazing if you guys could show me how to fix that. So, what got cut off was something important I want to show you. Since I bought this thing, I'm going to turn this light off for a second so you can see better. Let's see, does that work? See, I don't have my screen at the side. If you look here, since I bought this thing, it's only been able to charge to 75%. Now, in the video I did mention that the batteries are not charging past 7.6 volts, which they should be reaching 8 to 8.4. Now, so that's a troubling thing. Now watch this. Okay, so I'll turn this thing off. Let's take the battery pack out. Look at that. It only goes to 75% there too. See, 1, 2, 3. Fourth light is not lit. So yeah, it seems that this particular unit that I have received is flawed, where it is not able to go past 75%, which means either it was a design flaw in the factory, or I don't know, maybe they're just built like crap. But I think the latter is most likely. So anyway, that being said, you know, take what you want from my video. This is just me and my cynical self tearing something apart and explaining to you guys, and yeah, there we go. This is the true ending now. Alright? So, yeah, thanks guys. We'll catch you later. Enjoy.